Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting-edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Carlee Wong, who holds a Ph.D. from Princeton in applied mathematics and is currently an electrical and computer engineering professor at Carnegie Mellon. How are you doing today?
I'm doing well. Thank you for having me.
Thanks for being on the podcast. So to start off, I wanted to ask what made you choose your major for your bachelor's?
Yeah, that's a great question. So I was a mathematics major for my undergraduate degree. And the reason I chose math is just because I always liked doing math in high school. I was very fortunate to have the opportunity to do some sort of independent studies, almost like mini, very preliminary research projects with some of my math instructors. And they really sort of opened my eyes to what advanced math could look like and why it was sort of fun to think through kind of these puzzles and solve these sort of math problems. So that's the primary reason why I chose mathematics. The other one was that I realized it was sort of widely applicable to a lot of different fields like physics, chemistry, engineering, all that stuff. So I figured if I learn more advanced math and I major in math, then I'm not closing any doors to eventually specialize in some of those other fields.
So what was your experience like while getting your bachelor's?
Yeah, so I would say I had a very intensive undergraduate education. So I ended up completing my undergrad degree in 3 years, actually. So that involved, a lot of coursework and a lot of very intense academic work. Um, I guess what I would say I sort of took away from it is, of course, I took a lot of courses in my major, a lot of courses related to my major. And those were very, very fun. I learned a lot, and that eventually led me to my future career into graduate school. But I think what I would sort of tell high school students that was the most fun part about this is first, just making friends with others at school. I'm still friends with a lot of those classmates today. And I really believe that what makes the university so special is the people that you meet there, your classmates, your instructors, et cetera. So I'm very grateful to have met a lot of amazing people during my bachelor's and to still keep in touch with many of them today. And the second thing that I thought was really valuable, and this is something that really seems unique to the college experience, is being able to take classes on all sorts of random subjects that might sound interesting. Like one of the most fun classes I took was, beginner's art history. And I'm not an art historian or anything like that, but it was really interesting to just hear from experts, learn sort of what they do and what this field is like, and just get some background in the area. So I would really encourage people to, make room for these random classes, even if they're not going to be useful for your career, you'll learn something. And you're never going to have the opportunity to be able to talk to so many experts in so many different areas. And when you're a student at the university, they'll actually talk to you. You can take their classes. It's a really amazing opportunity to learn.
I know at Ivy Leagues like Princeton, you almost have to like do all these extra classes that you might not have to do if you're like at an MIT or something. And as you're one of the people who really likes that aspect, um, is there like is that true that you have to do way more of these classes at Princeton versus some other schools?
That's a good question. So I should say my education was entirely at Princeton. So I'm not totally familiar with requirements at other schools. My guess is there's probably more requirements in the sense that there are more sort of gen ed kind of requirements. I remember we had something like 6 to 8 gen ed areas, and we had to take classes to fill all of them. And that may not be the case at some of these more technically focused schools. But I think, it's always possible, right, to take classes outside your department and to try to explore, even if you're not required to do so.
Yeah. So what made you want to move on and get a master's and PhD?
Yeah, so there were a lot of different factors. One was that after I finished my undergrad degree, I didn't really know what I wanted to do. I didn't have a clear sort of job in mind. for what I wanted to do. And I knew I liked doing research. I had done a little bit of research during undergrad, and I thought maybe I wanted to do more of that. So the natural way to do more of that was, to go to graduate school and eventually to get a PhD. So I think that was the primary reason. The other reason was sort of looking at possible career opportunities. I realized that a lot of the things I thought I might want to do would require a PhD. So I figured I may as well, get that over with and go to graduate school now rather than try to come back later.
So what was your research about?
Yeah, so my research has changed a lot over the years. As an undergraduate, I primarily worked in two different areas. So one was on quantum control. That was with a chemistry professor. That was actually my senior thesis. And that was applying sort of quantum dynamics and mathematical models of physics to molecular interactions with each other. So that was one side of my research. And then the other side of my research, which ended up becoming my graduate research, and I guess is still related to what I do now, was looking at mathematical modeling of the internet. So modeling sort of how people behave on the internet, trying to predict how they're going to behave. And as an undergrad, I started trying to look at what are the economics behind all of that? Like, how are these service providers making profits? How are consumers being affected by the amount they have to pay, and the way that their pricing plans are structured and that sort of thing. So that was sort of my undergraduate research. Then for graduate school, I got really interested in this idea that you could mathematically model the internet, which wasn't something I had thought of, before starting that research project. And that ended up becoming my PhD dissertation. So my undergrad research advisor eventually became my PhD advisor. And since then, I've sort of broadened my focus, not just to look at the internet, but look at sort of network systems in general. As we've seen sort of all these devices now that have internet connections, we can start to ask questions like, what are these devices doing? How do we model how they interact, the data they're collecting? How do we make use of the data that they're collecting? All those sorts of questions.
Yeah. So what made you want to become a professor after getting your PhD?
Yeah. So I kind of realized in the middle of my PhD that I wanted to become a professor and continue in academia. And there were a couple different reasons for that. So one is that as a graduate student, I was fortunate enough to have the opportunity to co-found a startup company based in part on some of my work, specifically looking at some of these internet pricing strategies. And I actually took a leave of absence from my graduate studies for a year to work full-time at the startup. So on the one hand, I really loved, of course, seeing my work in practice, actually seeing it impact people. But I also started to realize that the way corporate life is structured may not be the best fit for sort of what I want to do in my career. So I kept having these situations where like I would sort of see an interesting problem and be like, oh, I want to go work on that. And then realize, wait, like that's not going to help the company's bottom line. We're a startup company. We can't be, spending resources on these distractions when we really have to get our product off the ground. So I started to realize that having the freedom to really choose what I wanted to work on, even if there was no direct financial incentive to do so, was very important to me and was really something that I wanted in my career. And that's one of the things that's great about being a professor, that you can sort of choose research problems that you think are interesting. And as long as you convince your graduate students that they're interesting, you have the freedom to work on them. And then the second reason I decided to become a professor was because I realized I really enjoyed teaching. I really enjoyed working with students. And being a professor is the best way to be able to work with students and to really see them grow and see them develop into independent researchers.
Yeah. So what's your research about right now?
Yeah, so my appointment right now is in the electrical and computer engineering department. So a lot of what I do is basically machine learning, but my specialty within sort of the broad area of machine learning is looking at machine learning in network systems. So network systems meaning things like, you have a bunch of devices connected to the internet and they're all kind of talking to each other. They're all gathering data and running machine learning algorithms. And what I study is how do they actually figure out, who gets to do what? in such a way that, everything is balanced, everything is fair, nobody is running out of resources or running out of data, things like that.
Yeah. So, do you also like the teaching aspect of being a professor?
Yes, I really enjoy the teaching aspect. So both of the classes I teach regularly are, relatively large classes for my university. So not that large by other university standards. But it's really fun to kind of get to meet a new group of students each year. Some of them get really, really into the subject, and some of them have even gone on to do research with me. And that's been amazing to sort of watch them grow from not knowing much about the subject to kind of becoming experts in their own little subfield. And in general, it's been very interesting, very valuable to just kind of see students absorb this sort of knowledge and go on to use it later, even if it's not with me.
Yeah. And what classes do you teach?
Yeah, so the two classes I teach pretty regularly, one is Introduction to Machine Learning, which is mostly a master's level course. And then the second one is Mathematical Foundations of Electrical Engineering. So that's a kind of broader survey of the math that electrical engineers need, which is mostly linear algebra and differential equations.
So, for someone who's an incoming undergraduate at Carnegie Mellon, and let's say they want to go in electrical engineering and computer engineering, what programs do you think that they should be looking into?
Yeah, that is a great question. So for someone, you said someone who's already an undergraduate or someone looking to become an undergraduate, right?
Well, I guess like during their undergrad.
Okay, yeah,
Yeah.
yeah. Um, yeah, so I would say, of course, there are required courses, right, for everyone who's an EE or CE or ECE major. So certainly you have to take all of those. But one of the things the department really tries to do, and I think we're relatively successful, is really trying to engage students in extracurricular activities. So we have like a maker space where students can go and just kind of like play with devices, build random things. We have hackathons that also encourage you to sort of be creative, learn new things. So definitely, I would say, try to take advantage of those sorts of opportunities. And I don't think those are unique to CMU. I think many schools have those sort of things. But in addition to that, I would say, don't just be a engineer who does well in class. Really try to think about how am I going to use whatever I'm learning in class? How am I going to apply that? Why is this useful? Can I connect this to, maybe my desire for leadership or my interest in this other area? Don't focus just on, getting good grades in your classes. Of course, that's important. But you're not just at college to take courses and get good grades. You're also there to meet people, to develop your interests, to really think about, who are you going to be as an engineer going forward.
Are there any particular clubs at Carnegie Mellon that you're interested in?
Yeah, so I would say as a faculty member, I don't get the chance to engage too much in student clubs. I know that one of the big things among our students is the buggy races, which happen every April, where students sort of engineer this, I guess, almost vehicle, where one of them rides inside it. And the goal is to essentially, go as fast as possible down the hill on campus. So I think there are a lot of clubs sort of focus on that and more generally focus on, just like building things, almost robotics, I would say.
So, if you had to give someone who's still in high school or doing their undergrad one piece of advice who wants to go down the same route as you in academia, what would you say?
I would say the most important thing is try to keep an open mind. As I said, I didn't even discover that my specialty exists until I was a junior in undergrad, right? And I just happened to take this random course, and I saw this professor was doing interesting research, and I asked him, "Can I do research with you afterwards?" And that led to my graduate thesis. So really keep an open mind. Think about what is interesting to you. Like, don't do research just for the sake of doing research. Do research because you really care about this problem and you really want to solve the problem. And try to get to know yourself, try to find your taste in picking these sorts of research problems, and be open to learning new things and learning random things that maybe you don't think are useful, but maybe can be useful, 2 or 3 years down the line when suddenly you're working in a new area.
All right, then. Thank you for joining me on the podcast.
Great. Thank you so much for having me.